So today we will not discuss any topic. We will discuss about the project. So whatever doubts you have, we will discuss because we covered one algorithm, that is the regression algorithms. So how you can include that to your project. That is what we discussed today. So if you see, I have given you one Python-based implementations of your Coursera course, right? So I'll open that. So here you can see that. Okay. So univariable or univariate linear regression, the code is also given here for a different data set. Now you need to understand what is going on in this code. So they are uploading one data set, right? Then they are trying to give a different analysis for that. Data.head will give you the first few rows. Then data.describe is giving some summary statistics of the data. Then plotting is happening.
Sir?
Plotting, yes.
Like in the starting line, header equal to none. What does that do, sir? While we are importing and reading the data.
Yeah, you just need to understand them. Header means it is a text file, but it is stored as a CSV file. That's why they are calling pd.read CSV. We have learned something about the pandas in Introduction to Data Science. Pandas is a package. It is similar to some database, local database. So you're reading this data, CSV file. CSV file looks like a Excel file. When you open an Excel, there will be headers. Headers means column headers. Whether the first, if you give header equal to none, then it won't consider first row as a column headers. If you write header equal to true, then it considers the first row as a column headers. That is not a part of the data. So each column will have a name. Something like in this case, header none. That's why it is giving its own index. 0th row, first row, like that, 0th column, 1 column. If you have headers, then these columns will have those headings. This might be some variable, let's say x1, x2, like that. You understand what I'm saying?
Yes, sir.
Okay. The best way is always what you need to do is you should go and see always read CSV. This is the function they are using, right? In pandas, the documentation should go and see. That is how one should learn. Not this, you should also write here documentation. So once we understand this documentation, then only you can do the project. Otherwise, it's because you don't understand what can be varied, what people look for that. So pandas.read CSV, this has all these inputs, file path or buffer, separator, no default, no default. Separators, most of the times it is comma, but some people may put a different separator, colon or whatever that it's. Delimiter, header. Header means infer. Infer means it should find out that itself. So all are something like numerical, and the first row is strings, then immediately it will find out that, okay, this is strings, that's why it may be column headers. So infer means it should find out itself. Names, no diff. This description is there again. parameters, file path or buffer, whatever that it's a delimiter header. You want header, right? What is header? Header int list of int default infer. Row number to use as the column names and the start of the data. Default behavior is to infer the column names. If no names are passed, the behavior is identical to header equal to 0. And column names are inferred from the first line of the file. If column names are passed explicitly, then the behavior is identical to header equal to none. Explicitly pass header equal to 0 to be able to replace existing names. So this you should understand. You should write and see. And sometimes they will also give you some examples down. Some example here, pv dot. It won't give you full, but again, it's you can prove how. But this you need to understand whenever you get doubt. So you should go to the documentation of that particular library and that method and go and see that it's in what context they are giving this value for that parameter. So header, we have seen header none. So when you give none, what it does, if columns names are passed explicitly, then the behavior is identical to header equal to none. So means from the data set, it won't get any headers because you are explicitly providing those column names. Okay. So where are we? We go back. Yeah. Yes. So plotting data. So this all thing you should write util functions like this. So data dot head, whatever that it's. What is important for the user, that first you should find out. Is it important for user to see the what is data? We are talking about a general user, right? We are not talking about a data scientist. Data scientist may have interest to see that it's how data looks like, all those things. But if we keep in our mind, end user is some non-data scientist, for them, is it useful or not? What is useful? That is what we need to think first. Or else, he is a data scientist, but he is not a programmer. The programming work we are doing for him. Whatever he want to do, let him do. That is another way of looking. That is much more inclusive. That it's two types. Keep the minimum what you need to present for the user without the ask is what? That is for non-data scientists and non-programmers. The second thing, if data scientists want further to probe without writing code, how do they get all these things? So then you may ask data scientist, let's say, show me the relationship between, visual relationship between dependent variable and independent variable. It's a univariate, right? In univariate, only one variable is there. Then immediately you should be able to show this. Initially, we will give command line options for him, all those options, 0, 1, 2, 3, whatever that is, select one option, then immediately we should give this. In that option also, you may ask that, let's say, if there are several variables, then if you want to see each variable versus dependent variable relationship like this, then you should mention the variable name or variable index, comma, variable index, what is the relationship? Something you should think proactively in two ways. One is what you can present without asking what may be the interest for the non-data scientist, non-programmer, means they want to use only your results, that's all. He want to predict means he want to predict how you are doing, why you are doing, what is visual relationship, all those things he may not be interested. Then second person is the data scientist, but he doesn't want to program. He want to use your tool, but he should get all this. So he may say that it's okay, some parameter you are using some values, then I want to change those parameter values. How can I change? By command line or later GUI and get the result. So that is the project. Now you can ask your doubts, right? What I'm saying if you are unable to follow. In univariate, it is simple. So you'll give one option for them, visual relationship between dependent variable and independent variable. If they want to see that, then they will click or they will give some input for that. Then you will compute backend, and this you will present to him. Or you'll store in a data in some folder, and you'll give the local address of that file for them to open. Is it clear?
Yes, sir.
Yes, sir.
Okay. Now, for a data scientist, it may also be interesting for him to see how cost function is changing based on your thetas, right? This is compute cost, this function, this is a util function, this will be backend. Some of the functions you can find here. Some of the functions he might not have written, but you may think proactively, okay, this also may be interesting for the people to see that. Okay, in linear regression, R square is one of the value which people see. Let's see whether it is good linear regression or not. When we understand how to evaluate these algorithms, then we will discuss more about them. Those also you need to include. So cost. So here is writing one function cost, is finding out cost, and finally we will also show how the cost is changing. Visual representation also, if you want, you can show that it's a cost change. Where is that? Is it the cost changing function? Yeah. This is theta naught, theta 1. What is the third one? J theta. So plot J theta against the number of iterations. So how do you, it's a, for each data set, it should work. Then the problems will come. Some data sets may not be in the format what we have written the code. Then you should be able to find out at the first instance itself, it is not in the format of what I want. Then you will see what the problems are there with that. If there are columns with non-numbers, then you will say that I cannot work with non-numbered columns because it's a mathematical equations we are solving here. Later on, you will find out if there are non-numbered columns, something like categorical columns. The next course will take more those type of things. How do you convert them to the numerical columns? So one hot encoding, different methods are there. When we learn that, we ourselves write those pre-processing steps. Okay, it is not in the format what we want. There are some null values, all those things. Let us go and understand, and we have our util functions. We will apply them to pre-process them. So we will convert non-numerical columns to numerical columns. We will remove, or how we will handle. If there are different ways, then which one will give optimized solution for us? That itself a code we need to write. Or if we want to give for a data scientist to try himself those parameters. So suppose if you want to change the method of handling null values, some people will remove all those rows. So if there is null in that row, then they will remove. Or if there are more null values in a column, they will remove that column anyway. That is not removed. That is one way. Or else some people will replace those null values. Okay, I don't have a here value, but the data provider did not provide us. I will compute something like average of that column. I will put wherever it is null, or median value, whichever in the middle. Or if it is a time series type of thing, then there is no meaning of getting average. I'll take yesterday's and means one day before, one day after average nearby. So different methods are there. We should give that option for the user by explaining that there are null values I found in this data set. These are the methods to handle that. So if you can also give a little bit description there itself, which method is good, in which case. So you may say that 90% of that column values are zeros, then it is better to drop that column. You will give that option, but ultimately you will ask user to choose if he's a data scientist. So there are two roles for our users. One is they are not interested what we are doing. They're not interested, let's say, to go through all those things. Give the best linear regression fit for my data set. And let me download that model. And whenever a new instance comes, which I don't know the outcome, I want to predict that. How can I predict? Give that model, then they'll download, and you should also explain how they can input to the new instance and get the prediction for that. That is for non-programmers, non-data scientists. Another is the second, you should keep in your mind, what is interesting for the data scientist, but he doesn't want to program that. So we should write that program. For him, only he will choose the options. So that is the second option. So you may initially develop for the first non-programmers, non-data scientists, get a simple, which is the very good fit in linear regression that you should be able to give. So initially we don't do lots of pre-process, all those things. We will simply mention that whenever you upload, your data set should satisfy these conditions. If you want column headers, you should clearly mention them that it's in your data set, you should have column headers. In your data set, one column should be identified as a response variable or target variable. Okay, so that we can identify. Don't think that always people will keep that response variable at the end of the data set column, last column. Some people may put in the middle also. So we don't know where do they put. That's why if there are columns, then they should identify that. Or else you can specify in the beginning, your column should be, your response variable column should be at the end of the all columns, something like that. See? Whatever you are assuming, that should be mentioned very clearly for the people who want to use this tool. So now, for the purpose of taking some data sets and work on this, you can enroll into Kaggle yourself. Then I pasted one link today. There are regression. There are some data sets are given here. So you can take them as a demo examples. Whatever you create, so you should also create, okay, I will give you 3 demos or 2 demos, whatever that it's with some data sets. For CLI, demo will be not that easy, but when you create a GUI, then you can show that it's your demo with these data sets. Okay, I'm loading this data set, then I get results like that, whatever that it's. Or you can show there itself demo example, select one of these data sets, because people may not come with the data sets. If they want to try out your tool, they don't have any data set or any particular problem in their mind. So they just want to know that it's how your tool works. Then they may not have the data set if you ask them to upload one data set, and they may not know how to analyze results, all those things. For that purpose, we ourselves will keep some of the data sets there so that they can try out our tool. So that is one idea. So you can take these data sets or any other data sets, that is up to you, right? But I think these data sets, sometimes if you submit the results, you will also see that how good results you are getting when compared with other people solving the same problem. So are they getting better results? If they are getting better results, you can think that I need to do something, some parameter updation or changing the method, what you are applying, handling null values or removing columns, removing all those things. So that also will give you some idea how good your tool is working. So that's why all of you should register for this Kaggle, sign in. Then, in fact, they will also allow you to code in cloud and share with others also that code in cloud. That is, I think that is free till last year, that is free only. I think still it is free. So you can also use cloud platforms to run your algorithms, to write your code, all those things. So first 2 weeks, we will simultaneously cover linear regression, logistic regression, SVMs, neural nets. So 4 algorithms will come. These 4 algorithms you need to add to your ML toolbox. So now one algorithm is over, but not complete is over. Still, we need to know that, let's see how we evaluate the performance, all those things, and the regularization, those things are there. Whenever they come, then you start adding them slowly. See, whenever you learn, that is also important. So I think I made it clear what is your project, what you need to work now. Where is this? Yeah, this is pandas. This data set description, all those things, get acquainted with this Kaggle. There is also a resource which I have just gone through. What is that resource? This is regression challenge. Yeah, so you can see that regression along with classification is one of the core techniques for working with labeled data and must have skill. Okay, this is logistic regression. There are courses also in Kaggle. Let's say if you are, you can also go through that. Learn about different types of regression, Poisson, linear, and logistic, and when to use them. Learn how to evaluate a model with diagnostic plots. So you don't need to wait to see if you finish something, because you are not developing algorithms, you are actually trying to understand the algorithms. Once you understand the algorithm, then you can move to the next topic. We will discuss in our classroom or whatever that it's in discussion sessions, but you don't need to wait most of the time to complete these things. You can also do on your own. There are many other resources. The aim is you should become very good applied machine learning engineer. So whatever the algorithms are already developed are available through open source. We should be able to utilize them to our best and get the best results for a given problem. That is the emphasis for this applied machine learning course. So you can use these resources also, but finally the evaluation is based on how you understand the algorithm and how you present that to non-programmer and non-data scientist. That is the first. The second thing is, he's a data scientist, but he doesn't want to program. How do I help him to think his ideas through my program or get results through my tool, so that he doesn't need to do any programming, but he can still use my tool and get all his ideas to be implemented. So I'll stop it here. If any questions are there, it's okay. Otherwise, you can start at simple thing. Change the data set in the given day. Then what you need to change, that you need to see. I'm trying to get back. Yeah, this one. So now here still somebody is writing program, right? So if you take this another data set as an input, then it should work. All this, whatever is required for the non-programmer, not data scientist, that should automatically shown there and give instructions for him. Your model is built. You can download from this your model. That is one. So for a data scientist, it may be interesting or not, but you give options. So get relationship visualization. This is one option you'll give. Then whatever data set is given, immediately it should be able to present this visualization. Similarly, visualization of cost function based on different theta 1, theta 2s. That is another option you'll give. And then let him change, let him work with, let's see, different random values, different alpha parameter, learning parameter. Then how cost function is moving. That you need to show like this. It's a, is it overshooting or is it whatever that it's a, you'll give a feeling for him so that it's a, he's writing programming and getting this. So how you change alpha at various stages. As we have seen, it's initially we'll take big alpha, but later on we will reduce that alpha to 10 power minus 3 something with factor of that. So cost function using gradient descent. So just look at this. Then how do you make it? As other people without writing this program for their data set, they should get this. You can also use multivariate variate linear regression. So here each individual variable they are taking, and so if there are hundreds of variables are there, independent variables, then there is no meaning of giving 100 of these things, right? One way is find which variables are mostly linear with the response variable, give them, or give options for him, which variable relationship you want. Then at that time, it's on spot, you will compute backend and get them that visualization. Then feature normalization, again, you will give options. Here they are using mean feature normalization. There is other option also. So both options you will take and run the algorithm, then see that it's which one takes lesser time, because this normalization is to reduce the time, right? Complex time. So which one is giving lesser time, that you will use. Then compute cost. This is another normal equations. Then if the data set is suitable to compute the normal equations, you can also give comparison. Let's say normal equations take this much of time on the. So visualizing the cost function through normal equation. So these things you start adding to your ML toolbar. And simultaneously, let's say if you have a member in your team who can help creating GUI, you can also ask them to help the GUI, so that it won't take much time at the end. They can also help you creating those HTML pages and how to render. In the first discussion which I have shown, that is the Flask thing. So Flask can also be used. It won't take much time for you if you can understand. Already, I think it's you may have one of the team member, as I told you, it's get from some who studied web. Let's see, backend. The command line interface will be always difficult. So you need to give different options there. You write in a form, then let them fill those values instead of asking, reading all those things. Still, that is required backend, but front end, it looks very nice, the user interface instead of the command line. That is the advantage. Okay. If you have no doubt, yeah. Please mute, right, if it is not related to the class. Okay. So I'll stop it here. Whoever want to discuss, they can be here. Otherwise, people can start at ML toolbox. First of all, understand this, whatever I have shown, how this univariate linear regression is used there. Then how do you change the data set? Simply calling one function, all those results should come for you. So if you have no doubts, you can leave this call. You can start working.
Sir?
Is it tomorrow holiday in your calendar?
No, sir.
Yes, sir.
Yes, sir.
Tomorrow we will not meet. Then we will meet only on Monday. So I hope that you will utilize this time. at least a basic one algorithm you will add to your toolbox. Then Monday, some of you may show that it's your toolbox. So give me a data set, or this is the data set. I change, I get all these results. So I have written one final main function which will call all those util things. They will store either in your computer folder, or they will present there itself. But presenting there on console may be a difficult thing. It's okay. You can store all those results. Then you can show me that it's in this folder. All results are stored for that data set. Little bit creativity you require, as I told you. You need to think now what is interesting for non-programmer, non-data scientist. What is interesting for a data scientist who doesn't want to program but still want to try out all these techniques what you are doing. Okay, somebody is talking. Go ahead.
I just have a doubt, sir, regarding the project. I was just looking. Initially, you just asked. So can I once share screen?
Yeah. Let me allow you. Okay. I think you can share now.
Yes. So this is the main thing that we need to do, right, sir? Like
Yes.
while doing. So here initially asked read the name of the response variable, like which is y. So here does it mean we need to just take the input from the like customer? What is the column that is the response, or is it like a data?
Yes.
This
The
step.
same thing. Yes, the same thing what you are saying.
For example, if I have 3 different columns like
Yes.
square feet of land, number of beds, and the price. If the user is saying price is the y value that he need to predict, we need to ask him to give the requirement that he is wanted. Is that so? Yeah.
Yes, sir. You can also say that it's if you don't give any input for the response variable, I'll take last column as the response variable. That is a creativity. Not to make it in Python, all parameters, they have default things, right? You can set a default thing.
Yes, sir.
Still it works, but you will amply clear that it's saying I'm considering the last column as a response variable. But if they want to change, let them change.
Okay. And the second point, sir, here we are taking the input or the data set. But I didn't understood these things are like of absurd response variable value for a given set of values of explanatory. Explanatory is the normal input that we need, and response is the y value. I mean the output. So what here we need to do?
Yes, this is the data set. This second part is the x values, right? Set
Yes,
of given set of values, explanatory variables is the x values.
yes, sir.
Third response variable values is y values.
Yes, sir.
Means to read that data set.
Okay, sir.
So as x matrix and y column.
Okay, I need to separate. I need to take the data and I need to separate the x values and y value.
So first you will say that it's what type of data set you are expecting from him.
Yes, sir.
So they should provide a CSV file or Excel file. They can provide both CSV file, Excel file. Then you need to write if function there. If dot extension is CSV, then dot read CSV will use read CSV something. If it is a Excel, then read Excel. Different methods are there, right? You need to think that it's if you don't want to restrict too much to the user, then you can give all options. Now, if you want to restrict, you can still restrict. I lost my power. I can still be able to talk. It's okay.
Okay. So after taking the input, I need to just give. I need to take x values in. I mean all the explanatory in x values as x values and y response as y values here. Then I need to check whether I have.
First tell him that it's what type of input is expected for data set. Is it a CSV file? Is it an Excel file? Or if you want to accept both, tell them that it's I can accept both Excel file and a CSV file also.
Yes, sir. Then I need to check does it has any headers or not, and I need to identify. Okay.
Because they said response variable, right? If that
Yes.
response variable, if there is no header, then it is difficult for you to find out which is the response variable. They might say that house prices, but when they give the data set, they don't have, suppose, headers. Then
Yes.
how do you find out which one is the response variable? So first you need to infer whether column headers are there or not.
So
If column headers are there,
if there are no column headers,
then you cannot work, right? How do you know that from the data set? Which
okay,
column
so
is
I can
responsible?
just raise an error like there are no column headers observed.
Exception, you can put exception, or you can put assert. If assert fails, then you can throw an error.
Okay, sir.
Sir, if no headers are present, what will be the response variable, sir?
How two headers will be present?
Nitish, can you once share the screen? Sir, actually in the third point, they have mentioned that if the column headers are present, then we have to identify the column name as the response variable.
Yes.
But if it does not contain any column identifier header, so
Mhm.
response variable will be the default one, right?
No, if you mention already response variable, you should be able to find out response variable from the data set. If it doesn't mention, then there is no reading of the response variable from the data set, right?
Yes, sir.
So when it comes to pre-processing, is it common for everything or like how we need
This
to
is
choose?
this we haven't studied much. Initially, we don't do this. We will just check that it's this data set doesn't suit to apply the algorithm. If there are null values, if they are not numbers, all those things, we will initially we'll write. When we complete the pre-processing steps, when we write the pre-process util steps,
Yes.
we will apply ourselves to the pre-process steps, and we'll also give options what type of pre-processing can be done for the data scientist. For non-data scientist, we will apply some of the pre-process steps which is more suitable, get the result. So this part will come as we learn more pre-process steps.
Sir, we need to divide the data set into training set and test set, right, sir? So
Yes.
that we have to do it randomly, or do we need to sort by using anything and pick the first 80 and last 20 in that way, or randomly we can do it?
So always you can use one default, as I told you, it's non-programmers, non-data scientists, they don't understand what is this train data, all those things. So usual procedure is if the data set is very big, then people will take 30, 70.
Okay, sir.
Okay. If data set is very small, then if you remove 30, then your training will not be sufficient. There is a k-fold test is there. So what they do is they take 10 parts, the data set. Each time 9 parts they use as training. Then testing, they use the remaining part. Means one part they keep out, remaining parts they put together, train on that 90%, predict the first part. Similarly, take out the second part, remaining 9 parts. So like that 10 test results you will get. Average of that they will take as the test results.
Yes, sir.
Okay.
So
That
will they pick
K-fold.
randomly, sir?
It's yeah, randomly only you can do that, but the purpose of when you are increasing, decreasing the learning parameter, you want to see that it's for the same data set, how this alpha parameter is giving cost function. Then you can say, you can fix seed equal to some number. Then always the training and test split will be the same.
Okay.
That is for understanding purpose, right? Not for the user's purpose. When we are building, we want to understand how alpha. If each time your data set changes, then you can't get the clear idea, because your data set changes, that has become a different thing now
Yes, sir.
to compare. So that is the backend thing. For data scientist, you may need to give that option, but for non-data scientist, you don't need to give all those options, right?
Okay, sir.
So provide plots for, this is clear, right? Each explanatory variable versus responsible variable to observe whether it has a linear relationship. So divide data set, this is also clear. Here I wrote 80-20. you see that it's a, this is your project, because you are going to use, as I'm thinking that it's a, if you become a really great data scientist, this toolbox should improve as you grow in data science field. So this should come along with you. Whatever problem comes, within minutes, it should be able to say that it's a, the initial solution is this. I use my data ML toolbox and get you solution. Like that, I'm thinking. So this is not just complete by end of this applied ML project. You can always keep this ML toolbox with you, update this, and think more proactively, creatively, so that it's a, the grand plan is you should be able to remove data scientist between our ML toolbox and the customer. So customers should be able to directly use our toolbox. That is the grand plan. Actually, some of you may take this idea and you can build your own toolboxes. By that time, it's in outside may come many toolboxes, but you will have your own toolbox. You will add many algorithms, many different fields. As I told you, it's I have built one for topic modeling. Many it's forecasting, you may have different toolbox. For other problems, image processing, you may have different toolbox, but all are putting together into one ML toolbox for us. So here we may learn 4 or 5 algorithms. We try to put those algorithms. But later on in life, as you go, progress, then you may add many algorithms to this toolbox. So whatever is covered, those things you can do still, because you can still fit a linear regression, give the predictions, right? Without pre-processing, if the data set is suitable to apply. Even without learning the how to evaluate these parameters or how to evaluate the fitting is good or not. Whenever it comes, then you will also add that to the toolbox. So here, fit machine learning model to data set, tolerance number, iterations. You know this tolerance, number of iterations, regularization. Whenever we get regularization, we'll also give that option. So evaluation metrics we haven't studied. When we study evaluation metrics, we'll use those evaluation metrics to get very good fitting. Now, whatever fitting comes, we may give it, see, because we haven't studied many evaluation metrics. Or if you have already studied in Coursera course, as I told you in Kaggle, ultimately you need to put all them, right? If you study on your own and add them, then there is no double work for you. No, I will wait, till it is discussed in classroom or a discussion session. Then you may lose some time also. So it depends on it. See, that's why you are 4 people. You can look at these things. These things I have written on my own. You can think more creatively. See, many things to be implemented. If it is a good toolbox, you can also add them. You divide among your 4 members. Okay, you concentrate on this. You concentrate on this. Let's see, at least for linear regression, first 2 weeks or 3 weeks, we should be able to get very good toolbox. Later on, the framework is same. You will change the different algorithms, parameters, all those things. That becomes easy for you to add SVMs or neural nets, whatever you learn. So don't limit yourself only for this. This I gave you some information that how you should be able to build your toolbox so that other people can use it without writing program. So provide plots for parameter values versus model for function. Just now we have seen theta naught, theta 1 such parameters there, cost function, that is one. Or if you implement both normalization, in both normalizations, if they want to compare which one runs faster or which one converges faster, you can also show that if I use mean normalization, my convergence is taking these many steps. If I use what is other normalization? Mean versus, yesterday we have discussed it, right? Simply divide by the ratio, something like max minus minimum. So that is this another normalization. You can use sigma or standard deviation to divide the value minus mu divided by the standard deviation. Other thing is instead of divide the standard deviation, you divide with the max of that data minus minimum of that column. So you can also show that. That is only for the data scientist purpose. Right? For other people, it doesn't useful anyway. So find the best fit parameters. For this, you need to understand evaluation metrics. Then only you will get the best fit parameters. So there are some methods, if you want, you can try out to fix the parameters. Some people wrote some programs, they are called grid search, G-R-I-D, grid search. So grid search, you will provide the range, then it will take all the combinations within that range and see that it's, because sometimes if you need to provide 2 parameters, then combination will change. So how many combinations will get? Many combinations will come. If only one is there, you can see that if I increase what is happening, if I decrease what is happening. If 2 parameters are there, then you need to see that one increase, one decrease, or both increase, both decrease, or other one increase, this one is decrease, something like that. It's combinations will come. So you may not be able to do all those things. That's why they developed one more library that is called grid search. You can see that grid search, you give ranges of each parameter. Then you may say that it's the first parameter ranges from 1 to 10, second parameter changes from 1 to 5. Then it will take first parameter. Then you will also give some step size. So next value should be try out for this is 2. Then suppose first one is 1 to 10 means 10 values are there. Second one 1 to 5 values are there. 40 combinations will come. So for those 40 combinations, it will find out which one is the best running your algorithm. Then again, you need to provide some parameters. You need to see the documentation. What is your optimization function? All those things. What is your evaluation metric to see which one is the best, those things. So that also you should implement at the back end. That is what this find best fit parameters based on model evaluation parameters. Then finally, you will give a confusion matrix if it is a classification. Otherwise, you will give a R-square value and how good you got the model. Then finally, they should be able to download your model and predict for the new instances. Any other thing? Okay, so I'll stop it here. Then again, we will meet on Monday. I'll give you some time for 1 or 2 teams. Let's see if they considerable amount of development in their project to give demo 5 minutes or 10 minutes, whatever that. That also will give other teams some motivation or some clues. Let's see. So I hope at least some of you are more caliber to take lead and guide others also in this team. Thank you all.
Thank you, sir.
Whoever is ready to give, they can also send an email that it's I built something which I can present. Then if there are many people, then we can schedule it, let's say, next day for some people, previous day for some people, like that. Okay. Take care.
Huh?
Happy Ganesh Chaturthi for all. Yeah.
I just have a small doubt regarding this cost function.
Mm-hmm.
So we have the like normally we have the cost function and gradient descent also. So like
Gradient descent is a technique.
yes, sir.
Mm.
Cost function. So we can find linearization using normal cost function using the technique of gradient descent.
Gradient descent is used to optimize the cost function.
Yes, sir. So like
There are 2 different concepts. Cost function is we are computing how much of error we are making by implementing this algorithm.
yes, sir.
Then gradient descent we are using to minimize that error by changing our parameters.
Okay, sir. So one is used to find the how much error is there, and the other one is to minimize that error.
Cost function is simply a formula, that's all.
Yes, sir.
Predicted values, observed values. If they are close, your cost will become less. If they are far from one another, then your cost will become more. So then we are defining a function to compute the cost, that's all, provided observed values and predicted values are given.
Okay, yes, sir. And gradient descent is used to decrease that cost. Like if it is
So
very
gradient descent is a iterative method which will continuously decrease the cost function by changing parameters.
okay, yes, sir.
Whereas other method is there that is called normal equations. That is a mathematical formula to get the optimized parameters. There is no iterative process. You can simply put them into that X transpose, I forgot whatever that it's, that equation we have seen, normal equations. So you put your matrix into there, then you compute those matrix inverse and then multiplications. Then you get directly those theta parameters there. But that has some problems. That is computing intensive. It takes more time, n-cube complexity. And it also has problems whenever you don't have the inverse for the matrix. First of all, inverse cannot be found if they are singular matrices. So there are problems, but that will give you same solution for all of you, remember, if you use the normal equations, because that is a mathematical thing.
Yes, sir.
Then
Yes, sir.
iterations, then your alpha parameter, what you start, all those things will be a different thing. Different people may get different answers, but they will also get close. Theta naught, theta ones may not be the same. But error is for both of you should come to minimizing. Then we will see that why we will get theta naught, theta one differently. Then how to keep them theta naught, theta one as small numbers instead of the big numbers. Those things. So normal equations is only for the study purpose, not for the implementation purpose. I think yesterday I made it clear by showing the advantages, disadvantages between both of them.
Yes, sir.
Hemant, you haven't provided the list of the teams, right?
Sir, I think I've shared a link, sir.
Did you?
Yes, sir.
Okay, 1 second. Let me double check that in front of you. With msitprogram.net, right?
Yes, sir.
So guide me, where is that? We'll see. This is
Sir,
my
in
MS
WhatsApp, I have shared you the link, Excel sheet link also.
link also.
Yeah.
WhatsApp, Hemant. Please check. Okay, group in this above link. Okay. What is its name? Here it is not opening. Let me go and see the drive itself. Shared with me. Hemant. Maybe your email ID. What is email ID?
Hemant Sangoji, sir.
It is not recognizing them. Okay, what is dataset name? Dataset, not dataset. The file name. File name is
1 minute, sir. I'm checking. I need to check. I've shared 2 days back itself.
Right. It's okay. It seems my WhatsApp is not connected.
Applied machine learning groups, sir. It is.
Applied machine learning group. Applied.
Sir, it is showing me that you have already opened and it is you're watching it.
Okay.
Maybe network issues, sir.
Yeah. It's okay. I'll go through that. It's not an urgent, but anyway, I'll come to that. Yeah.
Okay, sir.
So no more issues with teaming up, right? No, that is solved.
Yes, sir.
You got 6 teams. Right. So whoever is working in team of 3, then they may have little bit, let's say, consideration.
I'm working in team of 3, sir.
Okay. Yeah, they may have little bit consideration when compared with 4-member teams. Some of these things may take more time. You may implement later in your life. See them, 1 or 2 things. That's okay. The small team.
Thanks, sir. Sir, I'm leaving.
Thanks, sir.
The left hand.